Okay, thanks very much, and thanks everyone for coming. It's really great for us here, at UWS, to have such a distinguished group of people coming to support us opening the centre. Have John and Tony and Neville Weber from Sydney and a whole bunch of other people from all over the place and the rest of the university. So it feels like mathematics research is on the map now at UWS, and hopefully one of our goals is to, well, not hopefully, it is one of our goals to be on the map nationally. And of course, what Barney said is laid down the gauntlet a bit. We have very high expectations on us. I'm not sure whether they're higher than our own. We also have high expectations for ourselves, and I hope we can fulfill them. You might be interested to know that our first acronym was CRIMS, Mathematical Sciences, so we might retreat to that at one point in the future. That would also be a good acronym. Okay, so I want to just introduce you to the centre, what we are, who we are. I'm going to show you slides of the core members and just give a bit of the backstory into how we came to be. So then I'll finish with some of the challenges and the goals that we have for the future. So the first thing is that we want to do high quality research, and the reason we are a centre now is because we're already doing high quality research and we want to take it further. And the second thing is that as we considered trying to become a centre, and this I don't think that it's correct to say that I'm the ideologue behind the centre, because this really came out of a group of people who were active doing research, and we talked about this. I think Volker was there and Wei Zhang as well. And back in maybe 5 years ago, we started talking about how to form a research community, because we were on different campuses, and we still are in many cases. But we have people doing good research on their own and with collaborators overseas and in other institutions. How we can bring ourselves together and form a concentration or something which makes us visible and gets us working better as a team, perhaps for getting grants and for other support. So one of the first things we wanted to do was to grow research culture. So we all come from different places where you've got older universities with a more established culture, and it's a bit easier to operate in that environment. So how can we grow that at UWS? So I'll go through some more of these in a bit, but we need to have an active program of colloquia and visitors. We need new ideas coming into the university, workshops and conferences, and build a culture of communication and just sharing ideas. One of our distinguishing features is that we don't have a pure and applied divide. So we've pitched the centre, and I really think that this is a feature of our work, that we are on a continuum. It's very difficult to draw the line between pure and applied in many areas. Some people are very clear about it, but I haven't had this conversation with someone like Larry Forbes, for instance, in Tasmania, but it's very clear on what applied mathematics is. But I think it's a real continuum, and I think I'll try to convince you of that a bit later as well. And I think that while the university has a reputation and a tradition of engaged research and very practical things, we're working in an area which is very theoretical and abstract. So I think that in doing that, we are, yes, on the one hand, it's trying to say this, but we kind of fit the slogan. The university's logo, I bring you knowledge to life, because we're at the life end and the knowledge end. But that makes sense. But the other thing is that I think if the university wants to grow its research reputation, it's important to cut through a little bit. And it's easy for the rest of the community to have certain perceptions about what the university is. And we need to have stories that break that up a bit and say, well, the university does things beyond what you think it does. So I hope that having a Centre for Research in Mathematics will make that happen. So the story was, as I said, a small group of us got together a few years ago, and we thought, how can we establish mathematics on the map at UWS? We've been recruiting over the years. When we had spaces, we were recruiting quality people, good researchers and good teachers as well. We realised that we did have a concentration of quality researchers. And at the same time, the university was shifting its focus. It had been focused, I think, following government policies on producing large volumes of publications, for instance, and there'd been a shift then with the ERA to quality. So the university was focusing on select areas of quality and getting good ERA results. So these two things aligned very nicely for us when we were thinking about becoming a centre. So I'm going to now give you some numbers, because this is a Centre for Research in Mathematics. We have a core group of members of only 6 of us, and then there are a bunch of associate members and some adjuncts, and there are postdocs and PhD students and so on. Just counting the core members, we're publishing about 35 papers per annum, journal papers, and more than half of them are in what the ERA used to call ARA-star journals. We're not supposed to use those terms anymore, but we do, without really apologising for it. But if you want to continue on that, I can talk to you about it later. We've had a reasonable run of grant successes. We'd like more. We've got a couple going on at the moment, and last year we had 4 submitted, 2 near misses, which is 2 that we perhaps could have got but we didn't get. And this year we put 5 in. This is a bit of a stochastic process. We will get those grants eventually, but we feel like we're doing reasonably well. Always more to do. The ERA ranked us in the more recent era, the 2012 era, 4, which is above world standard in mathematical sciences as a whole, 3 in pure mathematics, and 4 in applied mathematics. So 3 means world standard, and 4 means above world standard. So that's a respectable result. It's not at the top, the best universities in the country, a couple of them were 5s, but there are a large cohort at 4. So we're pushing up into that. We don't have the critical mass that many of those universities have, but we have some quality research which is getting us those high ratings. So it's a really important goal for us to maintain those levels and continue to be regarded in that category. We've got a rather small number of HDR and honours students, 3 PhD students and 1 honours student, and that's a key goal, which I'll mention again later, just to grow those numbers. Since we've become a centre, one of those things is about bringing ideas in, bringing people in. So we've used our resources to bring in lots of distinguished visitors who typically come for 3 or 4 weeks, give a series of talks, collaborate with somebody in particular usually, and hopefully with a few more people, interact with the students and the postdocs. So there's several of these at the top. Gonzalo Aranda Pino and Wolping Tung and Gene Abrahams from Colorado. They came for an AMSI workshop, which we ran right at the beginning of the centre in the beginning of 2013. And hopefully next year we'll run another one of those. There's another one of those workshops or conferences on algebraic biology. Thanks, Barney. So we're hoping to keep running a series of workshops and conferences every couple of years. We have weekly research lunches, which are very informal. People chat about a topic they've been working on or a paper they've read. And we have colloquia where we bring an invited speaker every month or so during the semester to give a public talk. So these are the sort of key categories I think that describe the sort of things we do, but they're really all connected. It's a nice little complete graph. They're not connected all in the same way. So these edges, these lines don't all mean the same things, and they're really different categories of information. So just want to point out that papers are outputs. So these are the outputs that we think of when we produce research. We write papers. The grants are inputs that we need to fuel the research. ERA is like an evaluative process, so it's neither input or output. And these bottom 3 I think of as research culture, or a climate, the sort of environment that allows other things to happen. So if you don't have a bit of culture going on, a bit of research activity and community building up, then you miss out on those collaborations, and papers are more of an individual thing, and you don't get the benefit from your mass. And all of those things feed into the ERA, well, particular papers and grants. Okay, so I mentioned that I think we really are on the pure and applied continuum. So this is a picture of our core members along that continuum and our associate members down the bottom. And I'm going to give you a little bit of information about each of the core members. But the associate members, I'll put them also where I haven't consulted with them, but I've plonked everyone down here. And Lawrence, for instance, does sort of statistical computing. So this is Lawrence down here. So I think of him as a bit more applied, but he does some theory as well. Ray does mathematical finance in the middle. So while he does prove theorems and does a lot of very difficult analysis, he's also thinking about applications into the finance sector. And Leanne is a group theorist who does combinatorics and also mathematical education. So she does a lot of graph theory and all that sort of stuff, which is at the theoretical end, but also has many applications. So I'm going to start with Glenn at the applied end. So there he is, a handsome chap. Glenn's a computational statistician. I'm not supposed to laugh at that, Glenn. Glenn's an applied, computational statistician, and he's a real asset to us. I've put him right at the applied end because he's come from CSIRO and he's had significant time in industry with IAG and NRMA. So he has a very real sense of real world problems and an ability to solve them. He can sit down and solve problems. So he's our real asset in the engagement space. And he's got a postdoc, Jiping Hao, who was just up there taking photos, and Paul Fay, who's also a staff member in another school. Next is Wei Xingzheng. Wei is our longest standing member of the university. It's his 20th year this year, I think. And so he'll get a little letter from the Vice Chancellor, I suppose. Wei is responsible for roughly half of our publications. So that, I said we had 35 publications a year on average. I think Wei produces between 15 and 20 on his own each year. So he's a machine, and a very good one. They're all, when I say volume, they're also high quality. So he's a great asset, and I think largely responsible for our 4 in the era as well. So he's been here for a long time, but he had a very good record before that at Imperial, UWA and Curtin, and he's an IEEE fellow, elected last year for his contributions to systems control. Next is myself. So I put myself in the middle because I was trained as a pure mathematician in algebra, and now I do mathematical biology. And I use the algebra to model evolutionary systems. So I very often don't know whether I'm doing pure or applied maths. I was proving theorems about group theory to try to solve statistical problems last week, and I do a lot of stuff with bacterial evolution that require group theoretical results. So I think this is where maybe it's my prejudice, but I don't think there's a clean divide between pure and applied maths in many situations. Thanks, John. So I have a postdoc at Tiller that works on a grant that I have with Volker Gebhardt, and 2 PhD students, Sangeeta and Stuart, are both here today. And you'll hear from Tiller and Sangeeta a bit later as well. Next is Volker. Volker is our colloquium organizer, computational group theorist from originally, I don't know how far to go back to originally, but he came to us from the University of Sydney, where he spent a long time in the Magma group, which is a computational algebra package, computer package. So, he's got a very diverse group theoretical knowledge, and I've put him not quite at the pure end because we just wrote a paper using group theory to model bacterial inversion processes. So he's now an applied mathematician in the Journal of Mathematical Biology. And he's also been here for 10 years this year. Next is at the pure end of the spectrum, James. James East is our webmaster. Joined us in 2011, works on semi-group theory. So I still have hopes of getting James into applied work as well, because there are semi-groups that come into modeling some bacterial evolutionary processes. And he's an expert in these diagram algebras, and I think this sort of things. This is one of his pictures, and that one as well. That's not a diagram algebra. But almost all of the pictures on this banner are related to James's work. if not actually his, all of them. He's a very prolific researcher in semigroup theory. And lastly, but not least, our acting director, Rusbeh. Rusbeh Hazrat also joined us in 2011. So perhaps you may have noticed that we had about three of these 6 joined us in about 2011. And that really gave us that impetus to ask to become a centre. Rusbeh is another very prolific researcher. I think he is, of the pure mathematicians amongst us, he's producing more than any of us. I'm including myself there for some reason, but yes, and he came from Queen's, Belfast, and before that, Bielefeld. So he's come from very good pedigree, and he's you talk about continuums between pure and applied, but there are other continua around mathematics, and he's at the interface of algebra and analysis, which is another very interesting place to be. So he's working on levered path algebras, which are a very algebraic object, but have strong links to C-star algebras. And so last year he ran an anti-workshop here together with Aidan Sims from Wollongong to bring those C-star algebra people together with levered path algebra people. So this is an example of bringing ideas together from different places that we'd like to be known for trying to do. So I'm just going to finish with a few goals for the future. The first thing, obviously, is just to keep doing good research. I mean, there really is no other substitute. There's no substitute for just producing good ideas. And we have other goals that the university also shares, which is to grow our research income. We very much want to keep growing our ARC money, especially because they're postdocs and they help produce the culture. But we also want to diversify beyond the ARC. Through industry links and so on. So we're working on growing, as Barney suggested, we're working on recruiting an applied mathematician who's able to work with industry and help us do that. Building the research communities are kind of obvious, but this last one is a real key challenge, and I was very interested in hearing Barney's discussion of his interest in education, because this is a key goal for many of us in CRM, is to have an undergraduate program of some flavour that feeds strong students into our research areas, so that we have a supply of honours students and furthermore PhD students. And we think that that's our selfish goal, but the other side of the coin is that having a research centre in mathematics can hopefully be used to attract more students to the university who are interested in mathematics. And so I think there's a great mutual benefit to be had from having a centre and for the rest of the university to bring high quality students in. So that's all I have to say. Thanks very much. Thanks.